right, as we get started today, let's go and quickly review over some things we've talked about recently. We said every angle has two sides. What are the names of the two sides of an angle?
Terminal and initial.
Terminal and initial. When we put an angle in standard position, what does that mean, Quentin?
It means that one line is on the x-axis.
Which one?
The initial line.
The initial side on the
X-axis.
what part of the x-axis?
Positive side.
Positive x-axis.
And the other
Is wherever. Where does the vertex have to be?
on the origin.
At the origin. Vertex at the origin, initial side, positive x-axis. If the angle rotates counterclockwise, Ethan, we would say it has? Positive rotation. So of course clockwise would be negative rotation. If two angles have the same ending side, we refer to them as?
Quadrantal?
Coterminal angles. Coterminal angles. And how do we find coterminal angles? Back to Jamie.
Coterminal angles. We add 360 or minus 360.
Good. Add or subtract 360. Now, Jamie mentioned the term quadrantal a moment ago. What does that mean, Ethan?
It means that the angle formed is either, it sits like at 9 degrees, it doesn't have a quadrant, it sits in.
Okay, good. The terminal side is on one of the axes rather than in a quadrant. In what quadrant would a positive acute angle fall, class?
1.
Quadrant 1. What about a negative acute angle?
4.
Quadrant 4. What about a positive obtuse angle?
3.
2.
2. What about a positive reflex angle?
3.
4. 4, right? We talked about a new unit we could use to measure angles, except technically it's not a unit, it's unitless, but that's just mind-blowing. So we're going to say we have a new unit to measure angles in. What was that new unit we talked about yesterday, Ethan?
Radian.
The radian, good, the radian. And we said a radian, how do we draw a radian, if you will? It's kind of how we would define the radian.
Well, it's pi over 2 minus the...
No. Okay, so real quick, remember if you have a circle, any circle, and you would draw the radian by making a certain size central angle, how would you have to make the central angle?
You would have to draw another
Radius, right? But I mean, I'm drawing another radius. Is this a radian right here? What has to be true to have a radian?
The line opposite the arc has to be equal to the radius.
The line opposite the arc?
It has to make...
Somebody help.
It has to make an equilateral triangle.
No. Actually, that does not make a radian. If we have a chord equal to a radius, we have a 60-degree angle, but it's not a radian. We don't want the chord to be equal to the radius.
The arc.
If the arc, that's the key, if the arc itself is equal to a radius, if you were to flatten it out, if you will, if the arc equals a radius, then the central angle that is subtended is a radian angle. Do you remember about how many degrees that would be, anyone?
57.8.
57.3. 57.3 degrees approximately is a radian. But again, the way we define it, it's the central angle formed when the arc equals the radius, hence the name radian. And we said that there are how many radians in the full or in a complete revolution? How many radians in a complete revolution?
About 6.
A little over 6. What's a little bigger than 6? 6.28, which would be 2 pi. Okay, so if we behold the bulletin board, and I will help with the camera here as well, we can remember that 2 pi is a revolution. Okay, 1 full revolution, 2 pi's. So 2 pi is a revolution, and so therefore half a revolution, or 180 degrees, class, would simply be pi. So pi is 180 degrees. What 180 is to degrees, pi is to radians. And because of this, we could make a fraction of one over the other, and it would have to equal 1, because they're equal. If you put something over that to which it is equal, it must cancel to equal 1. And we can use that almost dimensional analysis style to convert from radians to degrees back to radians. You make a fraction. If you do pi over 180, you're trying to cancel away what?
Pi. Or 180.
you're trying to cancel away degrees, right? So if you multiply 72 degrees by pi over 180, you're going to cancel those degrees away, right? But if you multiply by 180 degrees over pi, you're trying to introduce degrees as your unit, and you're trying to cancel away the pi if there is one. And oftentimes there is, like 3 pi over 8 or something allows you to cancel the pi. So multiply by either pi over 180, 180 over pi allows us to convert back and forth between degrees and radians. We also talked about if pi is 180, then what would be 90 degrees? Pi over 2, half a pi, right? And so if pi over 2 is 90, then two angles whose sum is pi over 2 would be considered complementary. And if pi is 180, then two angles whose sum is pi would be considered supplementary. And so by subtracting from pi over 2 or subtracting from pi, we can find complementary angles and supplementary angles, and that's what we were working on yesterday. I want you for now to, let's practice with what we were doing yesterday. We did a bunch of odd problems yesterday. Let's take a few moments to work the evens, page 39 to 40, 2 through 32, the even numbered problems. Take about 5 minutes to work on these. Again, we're looking for exact values for most of these, unless they give you which they don't on the first page. So everything on the first page we're looking for as exact as we can get. Second page, there's a couple decimals you're going to have to play with when we work on these.